Welcome back to the Deep Dive. Today we're taking a really technical plunge into the world of distributed ledger technologies, DLTs for short.
And it's a world that can get complex fast.
It really can. For a lot of people, DLT just means blockchain. But the reality is so much more nuanced.
Exactly. And I think understanding the core architecture, the actual structure, is the key to, well, really knowing what's going on.
Before we get into the showdown between the different types, maybe we should set the stage. What are the fundamentals that all DLTs share?
Good idea. They all share three core principles. First is decentralization, the idea that control is spread out across many nodes, so there's no single point of failure.
Right, no central server to attack or control. Second would be transparency and immutability. Basically, the ledger is public, and once something's written, you can't go back and change it.
It's locked in. And third, and this is the big one, is the consensus mechanism. This is the algorithm, proof of work, proof of stake, things like that all the nodes use to agree on transactions and keep the ledger perfectly synchronized.
Okay, so that's the common ground. Our mission for this deep dive is to go beyond that. We're going to compare the three main structures: blockchains, directed acyclic graphs, and of course, hash graphs.
And we're going to do it through the lens of what matters for, say, institutional use, things like governance, performance, and even environmental impact.
Let's jump right into that architectural showdown then. First up, the original, the one everyone knows, the blockchain.
The structure is pretty intuitive. It's a linear chain. Data gets bundled into these blocks, and each block is cryptographically linked to the one before it.
So it's a sequence, block after block after block.
Exactly. And that linear model is what makes it so secure. If you wanted to break the chain, you'd have to recalculate every single block that comes after the one you tampered with.
But that security comes with a major trade-off, doesn't it? Speed and scalability.
A huge one. To keep that single undisputed chain, the network relies on competition. Miners or validators are all competing to create the next block.
And what happens if, say, two different nodes create the next block at almost the same time?
You get a fork. The network has to choose one and discard the other branch. We call that pruning the tree. It's like a growing tree that's constantly being trimmed back to a single trunk.
So work is being done, valid work, that just gets thrown away.
Precisely. It's computationally wasteful, and it creates a huge bottleneck. It's why Bitcoin can only handle about, 7 transactions per second?
Yeah, the sources say 7 TPS for Bitcoin, and even Ethereum's base layer struggles at around 30.
Yeah.
You just can't run a global enterprise application on that.
Which naturally led to the next innovation in architecture, Directed Acyclic Graphs, or DAGs.
This is a totally different approach. It gets rid of the linear chain entirely.
Right. It's a graph structure where transactions validate each other directly. So you don't need blocks and you don't need traditional miners.
IOTA is the big name here. They're trying to get that higher speed by processing transactions in parallel. But what's the trade-off they're making?
Well, they definitely gain speed. But security can be a concern. Without a centralized block being produced, the network's security often depends on just the sheer volume of transactions. If the network is new or doesn't have a lot of activity, it can be vulnerable.
Okay, so that brings us to the third architecture, Hashgraph. It also uses a DAG structure, but it seems to sidestep the problems of both blockchains and those earlier DAGs.
It does. The key is in that pruning metaphor we used. Blockchains throw away branches. Hashgraph, on the other hand, weaves all the branches, all the transaction containers into the final ledger.
Nothing is discarded.
Nothing. The sources claim this makes the architecture 100% efficient. And that efficiency comes from its really unique consensus mechanism.
Right, it's made of 2 integrated protocols. Let's break those down.
Let's start with the first one, the gossip about gossip protocol. It's how information spreads. A node randomly picks another node and tells it everything it knows.
But it's not just gossip, it's gossip about gossip. What does that extra layer mean?
It means they don't just share the data, they share the history of how they got the data. So if node A tells node B something, it also says, and by the way, I learned this from node C at this specific time.
So the entire history of communication becomes part of the shared data structure itself.
Exactly. It creates this exponential and provable history of information flow. And that foundation is what makes the second protocol possible.
Which is, and this is just a brilliant piece of engineering, virtual voting. For anyone listening, this is where the massive efficiency gain really comes from. The nodes don't actually send votes back and forth, right?
They don't have to, because every single node has a perfect, shared, immutable copy of that communication history, the hash graph. They know what every other node has seen, and when they saw it,
So they can just calculate the outcome.
they can locally calculate how every other node would vote on a transaction's final order.
Wait, I have to pause on that. They calculate the vote instead of casting it? That sounds like computational magic. What's the real-world gain from skipping the actual vote?
It eliminates enormous amounts of bandwidth and latency. In most systems, confirming an order means constant back and forth messages, asking, confirming, voting, tallying. With Hashgraph, once an event is in the shared history, consensus is just there. It's computationally derived almost instantly.
And that speed and efficiency leads to what the sources call the highest possible standard of security in DLTs. Hedera is asynchronous Byzantine Fault Tolerant, or ABFT.
For critical infrastructure, ABFT is absolutely the gold standard. The Byzantine part means it can tolerate up to a third of the network being malicious.
Okay, that's standard for a lot of secure systems.
Yeah.
But what about the asynchronous part?
That's the crucial bit. It means the system is secure even against network problems. So it can withstand, say, a DDoS attack that slows down messages or just normal network lag across the globe, and it still guarantees that transactions will reach finality in the correct order.
An order that is then immutable.
Yes, and this isn't just a marketing claim. The sources point out this ABFT property has been formally proven using the Koch-proof assistant. It's a machine-checked mathematical verification. You're dealing with cryptographic certainty.
And that certainty translates into some very enterprise-friendly performance numbers. How fast are we talking?
Finality, that moment of absolute confirmation, happens in 3 to 5 seconds. And the network can handle up to 10,000 transactions per second. That's a throttled number, by the way, for stability.
And speed is one thing, but predictable cost is another.
This is a huge selling point. Transaction fees are fixed in US dollars, not tied to a volatile crypto price. A basic transfer is around 1/100 of a cent, 0.00001. That gives corporations the stability they need to build a business model.
The tech, the security, the performance, it all seems designed for institutions, which leads us perfectly into the governance structure.
And this is where Hedera really diverges from the pack. It's governed by a governing council of up to 39 massive global organizations.
We're talking about companies like Google, IBM, LG, Deutsche Telekom.
Right. And let's just address the elephant in the room.
The centralization question. A skeptic would immediately hear Governing Council of corporate giants and say, that's not decentralized at all.
And the defense is that it's a necessary transitional step. The model is based on Visa's early governance structure. The goal is to bridge the gap between, radical decentralization and what enterprises actually need, which is stability and legal certainty.
So by having members from different industries and different parts of the world, they're trying to prevent collusion.
Exactly. And prevent the kind of contentious hard forks that can grind other networks to a halt. To keep it fresh, members serve staggered 3-year terms with a max of 2 terms in a row.
But the network is on a path to full decentralization. This isn't the final state.
Correct. It's a very deliberate 3-phase roadmap. Phase 1 is now, with the council nodes running things. Phase 2 will open up to permission nodes from other companies.
Phase 3 is the end goal, fully permissionless.
That's the plan, where anyone can participate in consensus by staking HBAR. But they're only going to flip that switch once the network is incredibly stable, with a full 39 council members and hundreds of those permission nodes running. It's stability first, then open the floodgates.
And they've made a massive move to ensure the core technology itself remains open and neutral.
A huge move. In September 2024, the entire code base was open sourced and given to the Linux Foundation under a new project called Project Hyro.
The Linux Foundation, that's a big deal. It guarantees vendor neutrality.
It does. It means no single company, not even Hedera itself, can control the code's development. So you end up with 2 layers of governance.
The Hedera Council manages the live network's operations and stability,
while the Hyro Technical Steering Committee, which is community-driven, guides the direction of the open source code. It's an attempt to get the best of both worlds.
Okay, let's pivot to the economics that power all this. The HBAR token. It has a fixed supply of 50 billion, and it's used for transaction fees and network security through staking.
And we saw a lot of activity in early 2025. There was an event called the Great Acceleration, which was the largest single quarter release of HBAR ever, about 3.8 billion tokens.
Why such a large release?
It was all earmarked for ecosystem development, grants, programs, basically trying to fuel the growth of applications on the network.
And it seems like the community had long-term conviction. The sources say that by late 2025, nearly 38% of the entire circulating supply was locked in staking.
That's a very strong signal. Now, speaking of fees, there is an important change coming up.
The price adjustment.
Yes. For the Hedera consensus service, the fee for submitting a message is going up from 0.0001 to 0.0008, starting in January 2026.
That's an 8-fold increase, percentage-wise. But in real terms, it's still tiny. What's the thinking there?
It's about long-term economic sustainability. As the network grows to include hundreds or thousands of nodes, the fee structure has to be robust enough to fairly compensate all of them. But even at that price, it's still incredibly low and, crucially, predictable.
And that sustainability focus extends beyond just the economics. The environmental aspect is a massive differentiator.
It's huge. Hedera is officially committed to being carbon negative. They purchase carbon offsets every quarter based on third-party audits.
Let's put some numbers on that efficiency.
Okay, a single Hedera transaction uses just 0.00000017 kilowatt hours of energy.
0.00000017. And how does that compare to, say, Bitcoin?
The source material puts a Bitcoin transaction at over 1,700 kilowatt hours.
So Hedera is roughly 10 million times more efficient. For any corporation with ESG targets, that's not just a small bonus, that's a game changer.
It's another key piece for enterprise adoption, which brings us to the actual services they offer, the building blocks for businesses. Let's touch on two. First, the Hedera Token Service, or HTS.
This is for creating tokens, right? Fungible tokens, NFTs, all of it. But why use HTS instead of something like Ethereum?
The difference is built-in compliance features. At the protocol level, HTS can support things like KYC, know your customer, and enforce custom royalties. That's non-negotiable if you're trying to tokenize regulated real-world assets.
Like we see with asset managers like Adradin, who are using it for money market funds.
Exactly. And the second major service is the Hedera Consensus Service, HCS. This is basically a decentralized logging service.
So you're not running an application on Hedera. You're using Hedera to notarize what your application is doing.
You've got it. You take any stream of data from your app, and you use HCS to get a trusted, immutable, and cryptographically proven timestamp and order for those events. It's perfect for when you have multiple parties who don't trust each other.
Like the ServiceNow example.
Perfect example. They use HCS to create an immutable audit trail for cross-organizational workflows and SLAs. So if two competing companies need to agree on when a milestone was hit, they write that fact to HCS. Neither party can ever dispute the record later.
So wrapping this all up, we have this unique architecture, this woven DAG. We have the speed from virtual voting, the mathematical proof of ABFT security, and this stable institution-led governance model.
It's a combination that delivers unparalleled speed and finality for applications where, failure is not an option.
And looking forward, there's one more big step on the roadmap to full decentralization. The sources mentioned the launch of block nodes in 2026.
This is a critical move. Right now, the network's history is stored on centralized cloud servers. Block nodes will replace that with a decentralized data lake. It will lower costs, reduce latency, and it's really the final piece of the puzzle required to make a fully permissionless network practical.
It really feels like a deliberate, carefully managed transition into a global, open utility.
Which leads us to our final provocative thought for you, the listener.
If decentralization is only truly useful when it meets the intense demands of the enterprise, world speed, stability, fixed costs, compliance,
and if Hedera's unique model of blending institutional oversight with open source innovation is the thing that finally bridges that gap, could this phased, deliberate blueprint become the necessary standard for all future critical infrastructure in our digital economy? Something for you to chew on.